Hello and welcome to Physics Basket. So let us get started with the continuation of the kinematics series, wherein we are going to attempt the problems on riverboat problems and projectile. Hello, and let's get started with the next problem that says that the maximum speed of the boat in still water is 27 km per hour, and now the boat is moving downstream at in a river which is flowing at 9 km per hour. The man inside the boat throws a ball vertically upward with 10 meter per second. Okay, so let's try to draw this. So these are the things that we have. The first thing is the speed of the boat in still water. So let this be the boat. No, this is the man. So the boat can go on a still water at 27 km per hour, and the water itself has a speed of km per hour. And this man, he throws a ball upward with 10 meter per second. And from the observer point of view, the range of the ball will be, because what will happen is, since this boat is moving and the ball is also given a velocity upward, so ball will have actually two kind of velocity. One is due to the boat on the running water, which is already going at 9 km per hour, so it will have some velocity called initial velocity ux in the x direction, and the since it has been thrown up by the man in the upward direction, so it will also have a velocity, initial velocity uy. And since ux is in the x direction, which is parallel to the ground, so it is not impacted by gravity, whereas uy will have an impact. So it is going to take a trajectory something like this, and finally it will fall somewhere here, right? So this is the range that we need to find. We need to find this range basically. Okay, so one thing is very clear, that the upward velocity with which the ball is being thrown is going to be impacted by the gravity, whereas the forward speed, or the speed in the x direction, which is due to the boat plus the stream velocity, is going to be the x direction speed, and basically it is going to be same because it is not impacted by any gravity. So first let us find this, what is ux. So ux is given in kilometer per hour. So for in still water it is already 27. So in downstream, which is already going at 9, so what will be the effective velocity of the boat in downstream will be 27 plus 9, so it gives me 36 kilometer per hour. And with this, let us convert this into meter per second, which gives me 36 into 5 by 18. So it is 10 meter per second. Why meter per second? Because this is given in meter per second. So Vy is already known, which is equal to 10 meter per second, right? So now I have the speeds already. So ux is 10 in this direction, and uy is equal to 10. So what is the range? So the time taken by the ball to fall down will decide the range. So if we know t, so which means that at one point of time the final velocity of the ball will become 0 at the top, right? So what is the time? Time will be t, time of flight will be t equal to u by g, right? Because we can, in the background it's already known, v is equal to 0, final velocity, so is equal to u minus gt. uy minus gt in this case. So from there we get that t equal to uy by g. So the total time of flight, this is like just to go till the top, so it will go back, right? It will go up and then it will go back. So what is the total time of flight? It will be t equal to 2 uy by g. Basically, this we should know. We don't have to really do this. So the total time of flight will be t equal to 2 uy. Uy is what? 10 by g. G is already, we need to take g is equal to 10. It's already given. So we can say 10. So this gives me t equal to 2 seconds. So with t equal to 2 seconds, we can find the range because ux is constant. It is not impacted by anything. So we can say range equal to ux into capital T. So in the forward direction. So that gives me 10 into 2, which is, this is 10, right? So this will be 20 meter per second. Okay. So it's not meter per second, it will be meter, right? We are finding the range of 20 meter. It has asked me to find in centimeters, of course, 20 into 100. So which gives me into 10 to the power 2. So
Hey everyone, please don't forget to subscribe to the channel for regular updates on JEE and NEET physics for class 11 and 12. Your small support can really encourage and motivate me to create more useful and high quality content for students like you. And also, don't forget to hit the bell icon so that you never miss any latest lesson and content. Thank you so much for your support.
yeah, so this is the next problem that we have. A particle is projected at an angle of 30 degree from the horizontal and at a speed of 60 meter per second. Okay, and the height traversed by the particle in the first second is h0. This is what is given, and the height traversed in the last second before it reaches the height h is maximum height. Before it reaches the maximum height is h1. So the ratio of h0 to h1 is what we need to find out. Okay. First thing is, whenever a body is uh, projected at certain angle theta, right, with a speed u, so it will have two components. One is ux, which is along the x direction. Obviously, it will be equal to u cos theta. And another one is the uy, which is impacted by the gravity usually, and this is equal to u sin theta. This is another thing. And now it says the height in the first second is h0. So h0 is in the first second, right? And the height in traversed in the last second just before it reaches the maximum height. So that is equal to h1, correct? This is the height. So what is the time of flight here? The total time of flight is t equal to 2u sin theta by g, we know. In this case, we can say 2 u is 60 into sin theta, sin 30 degree, right? Sin 30 is what? 1 by 2 by 10. So this gives me 6 seconds. So time when it reaches the maximum height is t for max h is equal to what? 3 seconds, right? So in the between 2 to 3 seconds, right, it moves by distance h1. That is what is given. And in the first second means h0, we can simply say u sin theta into t minus 1 by 2 gt square, correct? Because it is in the first second. So which is nothing but, let us
put it, what are the values? The values is 60 into 1 by 2 into t. T is 1 second in this case for h0, right? Minus 1 by 2 into 10 into 1 square, and that gives me 30 minus 5 is 25 meters. So 25 meters is what it travels in the first second, and h1 is equal to in the last second just before it reaches, right, the maximum height. So we can say we know h1, we know that on the nth second what is the displacement. So that is equal to uy plus a by 2 into 2n minus 1, correct? Is what is uy? Uy is u sine theta, so 60 sine theta is 30 in this case, right? It is 30. A by 2 here is minus g, right? So it is acting downward, so it is minus 10 by 2 into 2n. What is n? It takes 3 seconds to reach the maximum. So what is that actually? So this is the trajectory, right? So first second between 1 to 2, this is the second, what is the distance moved, and then this is the last second before it reaches, right? So nothing but it is the third second between second to third second. This is the third second, this is the second, this is the first second. First second already we found out, right? So first second is actually 25, and second we don't need to know, but third second it is asking just before reaching the maximum height, which is the third second, between second and third second. So we'll say 2n, so 2 into 3 minus 1, okay? So this gives us 30 minus 6, 5, this is 5, so 25, this is equal to 5. So we are asked to find, we already know this h1, we know s0 also, so we are asked to find s0 by h1, so it will become 25 by 5 is 5. So this is my answer.
So this brings us to the end of this current topic, and we will continue with the further problems on kinematics, wherein we'll discuss projectile and motion in XYZ. Thanks for being here.